Welcome, everybody. My name is Farhan Tahir. I'm a product manager here at Salesforce. I run all of the UI frameworks for Salesforce, so Canvas and Visualforce that you're well aware of, and Lightning Component Framework, which is the new one. We released it a couple of years ago here at Dreamforce. As part of managing the UI frameworks, there's a couple of sister teams that I also manage, namely instrumentation, which is our metric service. We are working on exposing it to our customers. And secondly, the security layer on the Lightning Component Framework, which is LockerService. Today, we're going to talk mostly about LockerService. I have a few slides to share to introduce the concept of LockerService, why it's important, and I'm going to pass it on to the developers from Welcome Suite who are visiting us from Ukraine, who will talk about how to lockerize your components and give a really great demo of lockerizing your particular components. And then I'm going to come towards the end and talk about what's coming out of LockerService in the next couple of releases. So Lightning Component Framework is based on top of our open-sourced Aura JavaScript framework. This was the first time we have open-sourced a JavaScript framework. The Lightning Component Framework that we expose to our customers, our internal developers also use to build the Sales Cloud application, Service Cloud application, and the Marketing Cloud application. JavaScript has been around for about 20 years or so. It's the 10th largest programming language today. The issue with Java services, since its inception, it has opened up a lot of security vectors because of the way it interacts with the DOM. The most notable one of those is cross-site scripting. About 84% of all web security attacks are in the form of cross-site scripting or XSS. It is JavaScript by injection. So think of a shopping cart website that you have, which is vulnerable to XSS attacks. A hacker comes in and puts some malicious JavaScript on your website, and now when your users come in and enter their personal information, that information is not only going back to your DCs, but it's also going back to the hacker, who may choose to use it however he may see fit, and obviously it will be malicious. So now let me try to bring this concept at home. So this is my representation of a browser with Lightning app running. In this Lightning app, you have multiple components, and components are coming from different namespaces. Some are from managed packages, some are from unmanaged packages, and even some of them are from provided by Salesforce. And here you can see all of these components are rendered on the same page. They are not sandboxed, and the DOM of each component is exposed to another component, which means via DOM scraping, one malicious component, just one malicious component, can read the data from any other component that is sitting on the same page. Point number two that I wanted to make here is also, because there is no sandboxing, if there is a bug or an issue in one particular component, it could affect your whole Lightning page. We wanted to solve this particular problem, and that's why we introduced the concept of LockerService. A LockerService is the first of its kind. There is no security, web component security model at enterprise level before LockerService. Okay, so LockerService will use some key JavaScript concepts such as strict mode, shadowing, to give you fine-grained access over your web components. Notice I didn't use the word iframes because LockerService does not use any iframes. It will enforce 5 different restrictions. Number one is strict mode, which is JavaScript best practices, coding best practice. DOM access containment, which means if you have multiple components on a page, your components will only have access to the DOM within their managed namespace. And if you're outside of the managed namespace, your component will not have access to the real DOM. We'll give you a fake DOM. You will, within LockerService, when it's enforced, you will also get access to intrinsic objects, such as arrays. But we will give you virtual or secure versions of non-intrinsic objects, such as elements or window. Earlier, I was mentioning that Aura is an open source JavaScript language. JavaScript framework that Salesforce has. And not all of the Aura APIs are supported by Lightning today. So with LockerService will restrict you to use the on-platform supported JavaScript APIs only, which will prevent you from using an unsupported API in your production org, and then because it's unsupported, we'll change something on our side which will break your application. And last but not the least is content security policy, CSP, which will limit the use or eradicate the use of unsafe inline and unsafe eval. So on this screen, on the left side, as you can see, I have 3 different components. The top one is coming from the UI namespace, which is Salesforce owned. Namespace 1 has 2 different components, weather and map component, and then namespace 2 has a finance component. And this finance component has some finance data related to your customers, so obviously it's sensitive data and should not be shared. On the right side of the screen, on the top right side of the screen, you can notice the real DOM. In this case, all of these components have access to the real DOM, and via DOM scraping, they can read the data which is presented by any other component on the same page. They don't have access to the backend data or server-side data, but they do have access to any data that is rendered in the UI. So now let's see how LockerService changes things. So on the right side in green is the UI input button component, which is Salesforce provided. Because it runs in system, because it's a Salesforce component, it runs in system mode and it has access to the real DOM. But the magic of LockerService is happening on the left side of the screen where namespace 1 and namespace 2 live. They are isolated from each other, meaning they cannot access the DOM of each component. So now that your finance component, which is some private data inside it, cannot be accessed by the weather component or the map component. Also, when LockerService is turned on, as you can see on the top left, the strict mode is turned on, which is ensuring JavaScript best practices. And also, there is an option to turn on stricter CSP via critical update, and I'll talk about it in a little bit. So those are a few introduction slides, but I think the main magic will happen when Yuri and Vladimir will present, so I'm going to hand off the presentation to them.
Thank you, Farhan.
Thank you. Yeah. So now we want to talk with you about Lightning LockerService, but from the developer perspective of view. Yeah. My name is Yuri, and I am Salesforce developer at SoftTeam, and today with me, Vladimir.
Hi, guys. I'm head of product at the Work Institute. And so thank you, Farhan, for that high-level review of why LockerService is helpful, why it was built, and why it sounds pretty meaningful for all of us that we want to protect our customers, our users' data from any malicious software and any potential danger. It's still from a developer's point of view, we encounter some limitations. Why they might be scary for the first point of view, in general, it's pretty easy to overcome them. So the general, I'd say, limitations for us as developers is the lack of access to the DOM structure of the page, I'd say, and lack of the access to the window variables, global ones. At the same time, as Farhan said, right, we are not anymore able to access unsupported APIs. So if you develop something according to the tricks and unsupported APIs, you still have to do some magic to make this working. So while this stuff looks pretty, I'd say, scary, again, lots of us have developed our Lightning components in tight deadlines, or we were not planning too much stuff, so we were using document get element by ID, document get element by class name. So all of the standard stuff that we've got to use in JavaScript development, we've done the same in Lightning. So now we'll need to change this a bit, and Yuri will show us how we can do this pretty well. In general, it's pretty hard to build a nice and complex Lightning application where we will be able to show you all the magic, how you can easily switch to the pre-Locker service to the Locker service enabled Lightning. So we've done a pretty small sample application, and now Yuri, please show us how things will stop working.
Yeah, thanks. So at first, let's have a look on a few of our examples to see just things that are normal able to do in Salesforce. So at first, we have 2 components. One with a red border with Lightning LockerService disabled, and the second one with a green with Lightning LockerService, of course, enabled. And also we have this blue component with a standard UI button. And at first example, we will try to reach this button value directly by accessing it from the DOM. So just in this simple way, by through the document. Yeah, it was successful for the first component, and we have an error for the second one. So now it means that you can't access something like that directly from your component. The second our example is how we can just set the custom window property, and after that access it in every other component. So it's way how we set it in our blue component, and this is the way how we can try to get it, so just by the window. Let's have a look. Yeah, we get this from our first component, and it was undefined in our second component because Lightning Locker Service has its own private window, so you can't reach this no more.
Okay, it looks like pretty simple example, but still, so if you see that, sorry to interrupt you, in Lightning components, it means that not so bad, everything not so bad, and there's maybe it's Locker Service enabled for this component, so you'll need to fix it a bit. So Yuri, how we can fix this quickly?
Yeah, of course we can. So imagine situation, you have two old components. One with a red border with account input, so standard input, and other one with a green border, it's a parent component, and it has table to display all related contacts for this account. So, and imagine, of course, that you need to enable Locker Service for this. Yeah, we still have error here. So now, of course, we need to find the issue, and after that, refactor this. Here's an issue, actually. It's a controller of our green component, and we can see that somebody just tried to reach this input value in very simple and little bit dummy way by just
regular JavaScript way to access something from the DOM.
Yeah, but not in Salesforce, actually.
That's cool.
So it's wrong now, and we need to refactor this. There are two standard ways how we can do this. The first one is a simpler, and it can be implemented only in the examples where we have parent and child components, so we try to reach something from the child. It's create custom attribute and use this attribute as an API, for example. And the second one, it's more common. It's just create custom event and pass the values by the events between these components. So what we need to do to refactor this? At first, of course, we will use the first example with the attribute, because we have simpler example here. Here's an attribute that we added, and also so it's attribute in our red component where we try to reach our value. And also we added the simple reference to this input text. Also, of course, we need to refactor our green component and change a way how we can retrieve this value. So here is it, just one line change, and here's two parts of it. So first, it's when we try to find our child component here by its Aura ID, and the second part is getting the value by the attribute name directly here. And of course, after that, we pass it to the helper and do the business logic. And now we can just test our refactored app. And it's successful.
So this means that in this way, if you have nested components, refactoring the way how you've done this previously, it won't require too much time. You just need attribute. And then in terms of code, instead of accessing via DOM, firing by some selectors, and it's not a fact that you find it with a correct selector. Instead of this, you just find the needed component and get attribute from it.
Yeah, so just 3 lines of changes.
Cool, but what about the more like complex example, like how we'll handle this with events and how much work we need to do this for this case?
Yeah, so here you can see actually the same example, but with a few differences. At first, now it's a components in the same level of the hierarchy. And now you can see the button here because it's kind of live search component. So on each change of this input, you should display some values in our green component. So let's have a look on this. Actually, yeah, it fails even on the initialization because Lightning LockerService blocks something here, and we need to find out what it was. Here actually our green component controller, and you can see that also there's simple add event listener here. From one component, we try to add event listener on other component and just get values every time from here. Now, of course, it's blocked by the LockerService, and we need also change this one. So the first step of our refactor will be creating custom event. For this, it will be just a simple event with one attribute and with type of application. So to pass our input string. Secondly, we need to change our red component and add at first a register event for this. So this means that we can just fire our events here of this type. And also we need to change the controller for this and actually add these lines to fire this event. So at first we get in this value here in red component. After that we create this event and push this input. And after that just fire this event. And finally we need to change our green component. Here is it. So we need to add register. Sorry. Oh, sorry. Yeah, we have the handler here. My fault. We have added a handler for this event of this type here. And also we change our controller a little bit. And we just get in the parameter from this event that we fire in our second application. Also, you can notice that in both examples, we don't change anything in helper. So we definitely not broke anything in our business logic. So just small changes how we can retrieve these values.
Can you show if it works? I don't trust
yeah,
it.
of course. So our live search. Sorry. Yeah, it gets some object and
so
contact.
This means that in this example, instead of using the relying on the standard JavaScript events, you initially you've had just one event listener, and you were relying on the regular DOM events from JavaScript. And now on, you're just taking a bit more control on the events. So you add publishing of the event. You control what exactly data is published there. And in the target component, you add a handler and you handle the data.
Yeah.
And also this means that in this case, you can even add more data to the event. So in case if you want to, pass some more information in the event, you can also add some more stuff. That's
so
cool.
You can even remove few such issues in one event.
Just be careful. So this means, guys, yeah, it's pretty easy. We were pretty scared. We were also doing Salesforce development, and we were pretty scared about LockerService. I believe many of us was skeptical about it. But from another point of view, changing it takes about 15 minutes or 20 minutes for simple stuff, and you just need to think a bit more about your events and how to handle them. As a benefit, you get the great security for your users, and you'll be sure that no one will try to interrupt the proper work of your Lightning components, Lightning applications, and that's cool. But we still need to mention a couple of more things, and one of the most important ones is that you are not able to use any random third-party JavaScript library. So Salesforce have done a great job on checking and confirming that the libraries with these versions and higher ones are safe to use. They are supported by Lightning LockerService, and you can very safely use all of them. You can also find the list of all the actual libraries and the versions in the documentation on the Salesforce website. Link is here. The presentation will be shared afterwards, and you'll be able to see get the direct link if you don't want to Google for it. So now you'll need to be a bit more careful. From another point of view, Salesforce does the job for you to ensure that the code you're using is safe. So it's kind of a win for us as a developers. Not too fast.
Sorry.
Another thing is that we just need to take into account that when we're working with the Lightning components of different versions. So Lightning LockerService was introduced in version 40. And when we are interacting with version 39 and version 40, we need to understand that the version 39 can still access the DOM items of the components with Lightning LockerService. This is because that Lightning LockerService is not like an outside shell, it's an inside shell, so it won't allow your V40 Lightning component to access DOM of any other component. But still, like lower versions will be able to grab the data from there, so you'd likely switch to the higher versions as soon as you can. And you need to take this into account. And the last point here, but I believe it's one of the most important, for those of you who are ESV partners who are working on AppExchange applications components, Lightning LockerService is a must-have requirement for passing security review. Or it's the first security review for your components, or it's the periodical re-review of your components. You need to pass the Lightning LockerService, it should be enabled. So if you're an ESV partner, if you develop your components or applications, just do it as soon as you can and switch it to LLS-enabled stuff as soon as you can. It's pretty easy.
Yeah, thanks, Vladimir. This is all from our developer perspective of view, and we can pass the word to Farhan.
Okay, so I'm just going to take a couple of more minutes and talk about what we have today for LockerService tooling and what does the roadmap look like for LockerService tooling. So today, I'm pretty sure everybody who's tried to get LockerService compliance, you've seen the LockerService Lightning CLI. It's a Heroku tool belt. Once you install it, it's a command line tool. Once you install it, and you run it against your organization, it will point out by line numbers what the offending code is, the reason the code is offensive, and will give you workarounds on how to fix it. So with this CLI command line tool, you'll be able to highlight down to the line numbers of each and every component where your Locker offenders are and how to fix them. The second thing that we have is the LockerService API viewer. So this is a list of all the browser APIs that are whitelisted to be okay to be used within LockerService. As you can see on this screen, the red one is safe eval, and that will never be supported. So green is basically you're okay to use them, red means they're never supported, and there might be some which are yellow in color, which means there's plan for support for them, they're just not supported today, and they will be in the next couple of releases. And in terms of the next release, which is the Spring 18 release, it goes out to production in Feb, goes out to Sandbox in Jan. We're introducing two new tools. One is the Locker browser. And the idea there is you will go to this browser and enter in your jQuery website address, which has all of jQuery's web UI tests. And when you run all of those tests, which are available on jQuery's website, it will return back with success or failure. And the failure basically means those are the aspects of jQuery that are not Locker compliant. So I think jQuery has about 40,000 of these tests on their website. And you can by clicking one button, you can run all of them. And it will report, the Locker browser will report back which ones are passing and which ones are failing and why they're failing. And obviously the ones that are failing are not Locker compliant. And any third-party JavaScript library, the big ones, all of them have these UI web component tests on their websites. You'll be able to run them, and Salesforce won't have to give you a list of the supported libraries. So these were the automated tests that were given by these third-party frameworks. But what if you want to check your code compliance for snippet of code that you have written yourself. So we're also introducing Locker Playground, which is very similar to the Locker browser, but it will take in your snippet of code and it will report back if your snippet of code is LockerService compliant, and it will also do some perf profiling on top of it. So both these two new tooling features will be available in the Feb timeframe with the Spring 18 release. And last but not the least is the plan for LockerService rollout. So the summer release was around the June timeframe, and in the June timeframe, with the June release, API version 40 was introduced. And any component which has API version 40 or higher gets Locker enforced on it. The reason we did that is Lightning components were introduced in version 36, so we didn't force Locker on 36, 37, 38, and 39 because we wanted to keep a promise or API contracts, which means with the new release, which is summer 17, we do not want to break your existing Lightning component by enforcing Locker on them. So we enforced them on version 40, and the same release, we enabled stricter CSP in Sandbox and DE orgs only. So you can play around with enforcement of unsafe inline and unsafe eval in Sandbox and DE orgs starting summer 17 release. In Spring 17 release, we will enable, via critical update, stricter CSP in production orgs as well as Sandbox and DE. The reason it's not enforced not introduced in production today is because there's a perf hit that my team is working on fixing. So we want to, when you have LockerService turned on, we obviously don't want performance regressions on your custom components. So we're working on that right now, and when we have that resolved, we will introduce stricter CSP in the Spring 18 release in production as well. And then we'll give you a release to get strict CSP compliance, and we will enforce stricter CSP in the summer 18 release, which will be June of next year, summer 18 release. We have about 10 minutes left, so there's a couple of ways you can ask questions. You can come up to the front. There's a mic, ask your questions, and we'll be happy to answer them. If you are shy, we will stick around afterwards, so you can come up to the stage, and all three of us will stick around and take any questions.
Is there anything like browser-specific things here, like our customers may be using old browsers and we are on the Lightning communities. Let's say we didn't enforce it. Once it is enforced, what should we tell customer? Like, do they need to use the latest browsers? Anything like?
So that's a great question. So the question was, what is the browser strategy? A lot of customers, especially if you have communities, you don't control what browser the customer is using. So what is the answer to a customer using old browser? IE11 is a great example. IE11 does not even support CSP version 1. We're on CSP 2 now. So we knew that, and specifically for the community piece, any browser, legacy browser, such as IE11, 10, 9, Safari 9, LockerService is not enforced. So if you look at the same component in Chrome, the latest version of it, LockerService will be enforced. But if a user comes in from community using IE11, LockerService will not be enforced.
I was just looking at the website. Can you remind what the colors were? And if there's no color, what does that mean? Excuse me.
Oh, red is it's not supported and will never be supported. Green is it's already supported, and the yellowish orange is to be supported, but it's not there yet, and we'll be working on it in the next couple of releases.
There were a bunch of rows that didn't have any color at all.
I will have to look and see why they're missing.
Okay, so maybe those will be updated in the future.
Yeah.
Okay.
I'll make sure I talk to the dev team and make sure they're updated.
Thank you.
Hi, we have built a custom Lightning component-based community, and with CSP, I think we see a problem where we need to get analytics, web analytics of our pages. Okay, now out of the box, Salesforce supports only Google Analytics, but we use Adobe Analytics. So how we are going to get the analytics out of the pages which are built using Lightning components and with CSP enforced?
So the question is, we're going to be enforcing strict CSP, which does not allow you to use unsafe inline and unsafe eval. And a lot of these libraries, the one, I forget the one you mentioned, but let's take Google Analytics. They are not CSP compliant, so they will use unsafe inline and unsafe eval. So the answer is the stricter CSP applies to Lightning experience only, which means the CSP and Lightning communities is much more open and less restrictive. So you will be able to continue using Google Analytics and the custom one that you mentioned in Lightning communities, but inside of Lightning experience, you will not be able to use them. And if you want to track metric for your pages using Google Analytics or any other inside of Lightning experience, then there's a couple of things. Number one, we are working, I also run instrumentation, so we are working on providing you all the insights that you need for your custom and standard pages in Lightning experience and S1 mobile. But if you want to implement your own, then there is a concept of Lightning container component. So Lightning container component is basically an iframe component, and because it's iframed, none of the Lightning security rules apply to it. If you notice the domain of those Lightning components, they're randomly generated. So there is no risk of inside the iframe scraping the parent component. So Lightning container component, if you want to build your own, but look out for Lightning instrumentation, which is a product that we are working on for both our customers and for partners in terms of all the insights in terms of number of page views, the EPT of your pages, so on and so forth for both Lightning experience and S1.
Just one follow-up question. With this strict CSP, are you going to stop us putting the JavaScript in HTML head of Community Builder?
No.
Because that's where we put the analytics script.
So community, because it's really hard to control what the customer is doing, not you as a customer, but your customers in the community. So community has a set of completely different security rules. So you can do that, you can still do that in communities, and there is no plan to take that ability away.
Will it have any effect on Jasmine and other JavaScript, or for that matter, Selenium, other testing, automated testing tools?
If they are using unsafe eval, then yes. It will block you, it will error out.
Just the eval, but if you were doing it against the component itself, running a Jasmine unit test or some other JavaScript?
Yeah, no, so it won't impact it. So so Lightning testing service went out GA in the winter release, and it's Jasmine based. We also have the Mocha version of it. So no, that's not affected. And in terms of testing, we're working on providing you locators as an API. So basically, release after release, right now, all the locators keep on changing, which means all the Selenium tests keep on breaking. So you want to introduce the concept of locators as an API, so they're part of the API contract, which means they cannot be changed, release over release, and then your Selenium test will be much more stable.
That sounds great. I look forward to hearing more of that in the future.
All right, thank you. Five more minutes, and if you guys are shy, then you can always come up and ask us questions one-on-one. All right, so let's end this here, and then if you have questions, we will stick around for another 5-10 minutes to help you out.
Thank you, guys.